Welcome to another OSU CyberLab video. We used Clipchamp's text-to-speech to make production more efficient and so that different voices can be heard in the series. We start off using a PowerShell script called by a batch file to create a set of Hyper-V VMs. Click on the File Explorer icon at the bottom of the screen. Navigate to the C drive. Then click on BIS Files, then PowerShell Scripts. Find the Start Firewall Lab batch file in the list, and double-click it to run the scripts that starts the lab VMs. The command shell will display its progress. The Hyper-V Manager window opens. When the script has finished, the command shell closes. Next, we will access the web configurator so we can configure our firewall. Click on the machine named in the left-hand column. Your machine name may be different. Find the Admin ManageNet VM and double-click. The best resolution for your session with the VM may depend on your setup. If the size is inconvenient, you can try a different setting. Log in using username isadmin01 and password adminpass. The machine opens to the Ubuntu desktop. Next, we create an alias that accounts for all private IP address ranges. Open Firefox. It may ask about refreshing or updating. There is no need to do any of that for this lab exercise. Type in the address for accessing the pfSense web configurator as it is exposed on the ManageNet segment. 10.0.4.1. Press Enter. Sign into the management console. User admin, password pfSense. These are the defaults. We would never use them for a real system. Navigate to Firewall Aliases on the menu. None have been defined as yet. Click the Add button. Then, enter the values as listed in the notes. We used the name RFC 1918 and added all three IANA defined private address ranges to our alias. Save the alias using the button at the bottom. Then apply the changes. Next, we will create the rules for the LAN, or as we also call it, the Office Net segment. We start by deleting a rule that allows IPv6. We don't use IPv6 on this network. And, you may recall that pfSense has a hidden automatic block rule that is present at the end of each segment's rule set. This means that devices on this segment will not be able to send IPv6 messages to devices on other internal network segments. Use the menu to navigate to Firewall Rules. Click on LAN to go to the tab that lists rules to be applied to messages coming in from devices on the LAN segment. When the pop-up, finally, comes up, click OK. All of our internal network segments use private addresses. So, we will start the rules for each segment by blocking all messages that target private addresses. This is intended to prevent an attack from moving from one segment to another. We will make exceptions to this comprehensive rule later. Using the menu, navigate to Firewall Rules. Then click on LAN to move to the tab that shows the rules to be applied to inbound messages from devices on the LAN segment. Add a new rule at the top of the list by clicking the Add button with an up arrow. This is to be a reject rule, meaning that it will send a response when a message is blocked. Change to protocol to any. We want private address messages to be rejected no matter the protocol. For the destination, choose single host or alias. Type R into the destination address to bring up a list of aliases that start with R. Choose the alias we just made, RFC 1918. Fill in the description and save. Then apply the changes. Now make an exception to the last rule by allowing messages from devices on this segment to enter the router if they target the e-com web server. This illustrates least privilege. We generally block private addresses, but we allow traffic to a single private address to support authorized activity. Add another rule at the top. Most settings are the defaults. But we adjust the destination. We specify a single host using the IP address assigned to the e-com server. 10.0.2.102. Then we set the port range to HTTP 80. And, as always, add an informative description. Save the new rule and apply the changes. OfficeNet is a segment with lots of different devices. ICMP will come in handy here. Add a new rule at the top. This time we will choose the ICMP protocol. ICMP does lots of things. We could be more specific and allow only some functions. We will allow all subtypes. For the destination, choose a single alias and the previously created RFC 1918 grouping. Good rule descriptions will help administrators maintain the rule set. Save. Apply. Most computerized devices need to access DNS to get things done. In the next rule, we allow OfficeNet devices to access the DNS service provided by the pfSense router. By now you should be pretty familiar with adding rules. In this case we allow both TCP and UDP protocols because both are used by DNS. The destination is set to this firewall, self. Instead of having a separate DNS server, we will use the DNS service built into the firewall. Our DNS service operates on the standard DNS port, 53, so we allow messages targeting that port. You know the rest. Add a description. Save. Apply. Generally, we don't want important network gear to be reconfigured from the internet. If we want to allow that kind of access to our own infrastructure, we should use a VPN or use RDP so we can better control potentially dangerous access. By default, pfSense allows access to the router from the first LAN segment. That makes sense on small networks. Further, a special anti-lockout rule is created hoping to keep people from accidentally changing a rule and thereby locking themselves out of the router's configuration console. But since we have a dedicated management segment, ManageNet, we want to disable this rule. Click on the gear icon for the top rule after noting that it is the anti-lockout rule. Find and click the checkbox that disables the rule. Scroll to the bottom and save. That finishes up the rules for the OfficeNet segment. Now let's work on the other segments. We will only make a few rules here. That's because these carefully protected segments don't allow much traffic. In practice, these segments would have more devices and, therefore, more rules. Navigate back to the firewall rules for the LAN segment. Put a check next to the 3 rules as shown. These rules are to be copied to SecureNet. When the paste pop-up pops up, choose to copy to SecureNet. The first rule listed for the SecureNet segment is a leftover rule allowing any IPv4 traffic into the router from devices on this segment. Delete that rule as shown. It still may well take a long time for the pop-up. Click around and wait it out. Next, we will copy rules into the DMZ Segments tab. The instruction document lists all the steps, here we just show them. We delete the first rule on this segment, just as we did for SecureNet. And, again, we wait for the pop-up window. We want the carefully managed and controlled devices on ManageNet to be able to access all devices on all internal segments. So the only rule we leave here is an allow all rule for IPv4. Remember that the default block rule is still lurking at the end of the list. So, IPv6 traffic is still blocked, even on this segment. Next we will explore how we allow a connection between the web server on the DMZ and a database server on SecureNet. The steps we have taken so far have blocked that traffic. We will want to open it back up. We will start by opening up a new tab in Firefox so we can attempt to open a web page. The IP address for the server, and the page, is 10.0.2.102. Click on the one link there to open the web application. It is supposed to allow you to vote for a band. Right-click and view the page source. An error has occurred, so the page is incomplete. We know why. It is because we blocked traffic between the web and database servers. Take a look at the HTML code. To show what is happening, we will now turn on logging for the reject rule that is preventing the app from working. The steps are listed in the instructions and we click through them here. The relevant rule is on the DMZ segment. It does not allow the web server to connect to the database server. Edit the rule to make log entries when it is applied. You just have to check a checkbox. Save the rule and apply the change. Now we will go back to the web app and refresh the page. This will make the web server again try to connect to the database. It is still blocked, but this time a log entry will be created. System logs are accessed through the status menu. Choose Firewall and move to the bottom of the list to see the most recent entries. Now that we know what's happening, we will create an exception to the block rule to allow MySQL requests from the web server on the DMZ to the database server on SecureNet. Use the menu at the top of the page to navigate to the firewall rules for the DMZ segment. Add a new rule at the top. We don't want to allow all communication between servers on the two segments. We only want to allow traffic initiated by the single host web server at 10.0.2.102. And only connections targeting the database server at destination 10.0.3.103. And, even more precisely, we want only traffic sent to port 3306 on the target server. That traffic uses the TCP protocol. 3306 is the default port number used for queries passed to a MySQL web server. If things work as hoped, the web page will now load properly, and will support the voting functionality. Sure enough. When we refresh, the page loads completely. The names of the bands and current vote tallies were retrieved from the database. The application now tallies additional votes and even accepts write-ins. Note that this app was designed to illustrate security flaws. You can try out SQL injection and learn more in the appendix in the lab instructions.